Hello, welcome back. In the previous episode, we took a peek of the MX9 data structure. In this video, we're going to process the MX9 trajectory in Pospac software package. Let's launch Pospac. Create a new project. As you may remember from last video, the raw trajectory is stored in Pos1 folder. Simply drag and drop the first file into the plan view. Then all the following files will be recognized and taken into the project. Pospac starts downloading the ephemeras automatically. Make sure you have internet connection, then just wait until the rover antenna spec window pops up. We can leave the manufacturer as a Planix, but change the antenna type to TW3870 Talisman. You may see a warning like this, but it's okay to ignore it for now. The magenta line string represents the real-time trajectory. It covers the whole mission, but only a few segments have actual run data collected. We will see those runs later in TBC. From Project Explorer, we can right-click Mission 1 node and check its properties. My personal preference is to change the mission name in the format of year, month, and day, but feel free to rename it to anything else. Save the project. It's a good idea to save that project to the original MX9 data folder. Later, TBC will search for the output from this project, and its starting point will be that data folder. You may name this project into any name. Now it's time to bring in the base station. Here, I am using the Trimble T02 file format, but it also works when your base station is in the Rhinox format. Drag and drop it in. Since Pospac supports importing and using multiple base stations for one mission, we need to tell Pospac which station will be used. Expand the base station node, right-click, and select Set Base Station. Pospac will run a quality check. When it finishes, it will estimate how much area may be covered by what solution. For example, the fixed solution, the float solution, or no solution. Click OK to close the window. A blue flag marks the base station in use. One more thing to take care of is in the project settings. Go to GNSS inertial processor and then lever arms. Slide the standard deviation bar to the very left. Since our engineers have measured all these values precisely down to millimeter level before shipment, and all the components are living in a rugged shell, we will not give Pospac too much freedom to modify these initial values. We're now ready to run the GNSS inertial processor. If you're using a base station network or multi-single base method, you may see a different GNSS mode here. Click Run and let Pospac do its job. A green line string now appears. This is the smoothest, best estimated trajectory Pospac generated. You may get a clearer view by turning off the real-time layer in View Filter Manager. To see more details, go to the Reports tab, Display Plots. My favorite is the second node, Smooth Performance Matrix. Select the first 3 nodes in it, right-click, and Display Selected. Besides the mission initialization at the beginning and the cooldown period at the end, the position RMS in north, east, and down direction are all within 3 cm range. A lot of other QA/QC information can be found from the left side, so explore them as needed. Now save the project again. Back in the MX9 data folder, let's check the output of this project. Go to the Pospac project folder, then mission name folder, processed. This SBAT file carries the new trajectory information and is what TBC needs. Next time, we will launch TBC and show you how to import the full MX9 dataset. See you then.